Here's a little challenge which I'm going to have a go at. I've not done this before, but this Uniace 100, the chrome was very badly marked on the top. Very badly marked. So I have the grand plans to try and re-chrome it. Taking the front panel off is not easy. Apart from a few screws to hold things in, and also plastic clips, there is also a lot of glue. So things like the plastic clips here would not unclip, because not only was it clipped but it was glued. It's been quite a job getting into it. Now, in order to spray, ideally I would now like to take the front pieces off. This piece here came off fairly easily. Not much glue holding it, you can see just a few spots. That came off. But the rest of it is not coming off. It just doesn't want to. And so I don't really want to do damage by forcing things off. Because it's very old, delicate, might damage it. So now the plan is going to be to try and use masking tape over the front. And I'm going to then respray it with chrome. I don't know whether this is going to work, never tried it before, so we're going to carefully mask as much as we can of the front. We've taken off the damaged chrome along the top completely, and all round the other side I've roughened it up just to help the chrome paint stick. So a bit of very delicate rubbing down, and I'll do a little bit more shortly. Delicately rubbing it down all around the edges. And then we're going to put some masking tape on it and try to spray chrome. I've no idea what's going to happen, how it's going to work. Never tried it before. So it will either be successful or a disaster. I shall let you know. This is the Uniace 100 that I attempted to chrome, and I'm very disappointed really. It's not chromed at all really. It's just like a grey, like the old aluminium paint which you could get many years ago. There's very little shine about it, but I mean, you compare the knobs, the chrome shiny knobs with the colour of this. Let's turn it over and show the underside. There we are. Just compare it with the chrome of the knobs, and then compare that with the lid of the paint. Let's get the paint tin lid off if I can. Oh. There is the lid. That is what it's supposed to be, and as you can see, the actual chrome where I've sprayed it, it bears no resemblance at all between this lid, which is as it should be, and what you finish up with. So that's a joke really. That's a joke. They sell that as chrome, but it isn't. It's a joke. It's a con. But I suppose if you read the small print, they always say on these things that there might be colour variations or whatever between the sample on the lid and what you get. There's always some small print about colour variations, isn't there? But that and that, there's no comparison. And this is Paint Factory Colour It Quick Drying Paint, all-purpose spray paint for interior and exterior use on metal, plastic and wood. Chrome effect, gloss finish. I mean, it's not even gloss, it's matte. I've actually gone over it with some lacquer to try and give it a shine. But you know, I did everything they did, and I bought this one specifically because it mentioned suitable for use on plastic, whereas some of the others that you get, they don't say suitable for plastic. So that is why I chose this one. I know some brands I've seen on videos on YouTube look a lot better, but they don't specify that they can be used on plastic. So does anything in small print: preparation, directions, cleaning, caution. Due to printing limitations, the colour may vary from the cap and can colour. There we are. Printing limitations. That is why that doesn't look like that. Printing limitation. Well, printing limitation, well, I've got to be polite. I don't want to be banned. But that's the answer then. That is the reason that this silver looks nothing like that silver. It's due to a printing limitation.
Well, as you've seen, I'm very disappointed with the attempt at chroming that case. I'm very disappointed. I may revisit chroming a case again in some other video with a different type of chrome spray. I certainly wouldn't recommend that one. Right, well, let's move on. And we'll do a few other tests on this radio. I have tested and aligned this some time ago, but it's such a long time ago I really can't remember what was what. So I'm going to set it up and do some more tests. So here we have my power supply, a Shaman power supply, which I use for everything. It goes up to about 20 amps, I think, something like that. It's quite substantial. I chose this one because I like the idea of the cigarette lighter socket on the front, because then on all the CB radios I work on, I always fit a cigarette lighter socket, and it plugs in conveniently for any tests. So I really like this power supply. But it also has its downside in that there's no meter on it, so you don't know what current you're drawing, and the main connections are a terminal on the back. So to run my my actual CB radio in the workshop here, the 6900 style, in my case it's a KPO DX5000, but it is really a 6900, as we all know. That has to be connected to the terminals at the back, which is a bit of an inconvenience because I can't easily get to them. So that's the power pack, and we've got the Uniden Uniace plugged into it with this car lighter socket. An interesting other little box we've got here is that little Eddystone die-cast box there, which you can see. I say Eddystone die-cast box. They're no longer made by Eddystone, but again, when you was brought up in the ham radio of the 50s and 60s, everything was Eddystone die-cast boxes. So that was made by a guy in Russia. They're advertised on eBay. It's got a little toroidal device inside it, and it provides a coupling point, so your aerial from your CB radio goes in that, the lead from the CB radio goes to that, and then the other side of it goes to a dummy load or your actual aerial. And then you've got a little BNC socket on the side which gives you a low output, which you can use to feed a frequency counter or oscilloscope or any other piece of equipment that needs low power, such as my deviation meter. Years ago I was able to just use a little telescopic aerial in the front of my frequency counter and measure my frequency that way. But now I have a mobile phone mast next door putting out vast amounts of power, and so the only way I can use my frequency counter is by a screen coupling. If I just stick a little aerial in the front of it, well, all I'm doing is reading the frequency of the mobile mast. Also there we have an extension loudspeaker. That's a bit more than it seems, because I plug that into the rear socket on the back of the CB radio to provide sound output, because quite often I disconnect the speaker in the CB radio when I strip the cabinets off it. But it has a bit more in it than that. It has a little isolating transformer, which again goes off to test equipment such as a cyanide meter, and so therefore I've got a completely isolated from DC one-to-one transformer to take the audio from the CB radio to the cyanide meter with no problems of earth loops or anything like that. Here we have the cyanide meter all ready and raring to go, and above it we have a simple little power meter. It's only a very simple basic one, just to give me a rough idea of the wattage coming out of the radios. It's by no means as accurate as the old bird through line which I used to have and use, but then these days those are so expensive. It was expensive years ago when I had one, but now the cost of running one of those with all the elements, I just can't justify it. The frequency counter is a bit of an eBay bargain. It's a radio spares model, and of course anything that comes from radio spares is really good professional quality. And it's a Sage or Sage, S-A-J-E, but it's a make and model that's no longer available. The company that made them soon went out of business, and so that was a real eBay bargain, because it was an unknown brand. I got it at a really good price, and it's got the modern LCD display, which means it's not all that old. There's a lot of frequency counters out there on the second-hand market using the LED displays, which rather gives their age away. Right, well, having said all that, let's zoom in on something if we need to. Well, the problem is, as you can see, we've got a reflection from the lights on the power meter. So let's see if we can zoom in on it a little bit. No, we're still getting too much reflection from the lights, so we'll have to move the camera angle a little bit. Take it up. There we go. Right. We've got rid of that. So now we can key up. So let's key up and see what sort of power we're getting. And there we go. High power, it's about the 4 watts. We've got a low power on this radio as well, and there's a low power setting about 1/2 watt. So that is fine on channel 20. Now we'll move over and have a look at the frequency counter. Now, because I've got it coupled through this Russian guy's box, it's reading 0, which with no signal, which is brilliant, because if I use a pickup wire or any other means of measuring it, I'm getting all sorts of weird readings because of the mobile phone masts. So there we are. Now we'll key up and see what we get. There we are, 27.7 27791.361. So again, it's not a terribly critical reading because the channels, the CB channels that we use are very wide. They're 10 kilohertz wide, which is really wide. So you don't need to worry too much about the actual frequency. You could go fanatical and try and get it exactly on frequency, but there's no point. As long as it's within a kilohertz or so, it's not going to make much difference. It's going to pass through the channel from one CB to the other. So that's near enough. That's within about 300 cycles or so, where it should be 200, 300 cycles. It's fine. No point in trying to get any nearer. And in a lot of cases, with a lot of CB radios, you can't get any nearer. There's very little adjustment. So that's fine. It's on frequency. It's got the high power, low power switch working. So that's all fine. Now the next thing, which is a little bit more critical, is to check the deviation. The deviation is how wide the signal is when you're speaking, because it's FM frequency modulated, and so if you turn it up too wide, it splatters into the channels on either side. It might sound remarkably strong and powerful, but it causes havoc on the channels on either side if you turn it up too high inside the radio. And if you turn it up if it's too low, of course your modulation is too quiet. So you've got to reach some kind of compromise there. You have to get the modulation so it is the right sort of deviation setting, so you get the maximum allowable audio without splattering and causing chaos on the channels on either side. And so the recommended setting is about 2.2 to 2.5 kilohertz peak deviation. So many radios that come into the workshop have been tweaked and twiddled by experts. I say experts. They've turned the deviation way up, and it sounds really powerful and loud and booming, but it's causing chaos. So to measure that, we have to have a modulation meter or deviation meter. For FM, they're usually called deviation meters. Sorry, deviation for FM. But if you have one that can handle AM or FM signals, as I have here, then they call them modulation meters, which is a bit confusing. So we'll swing the camera around now, past the scope. I do have a scope, as you see, but it's the least used piece of test equipment. I've owned scopes ever since the 1950s, but in practice it's always the least used. People say they're very popular and very useful, but for the kind of work I do, the scope is the least used. I have used it recently, doing some tests on CB microphones on these power mics, but not all that much. Okay, right, there's the modulation meter now. It's not switched on yet. We'll switch it on. Oh, I've got to find the right place to switch it on. Put power on it. Excuse me for getting in front of the camera. Now the modulation meter is on, and the meter goes to full scale, and the little LED in the top right hand corner is flashing to indicate it's got no signal. So now what we have to do is connect it up to that sensor box, to the die-cast sensor box, so it can sample a small amount of RF when we transmit, because it's got a maximum input. Let's have a look. Of a quite low. It says on it, input a maximum of 3 volts. And so you've got to be very careful how much you put in it, because you could damage it. So I'll now move the little connector from the frequency counter where it was sampling the signal, because again that can't handle much input. I'll move that to the modulation meter. Okay, now the cable is moved over. Now the modulation meter is a very professional Rayco Dana version, which can handle AM or FM, and it can be used for measuring the modulation of broadcast transmitters. It's got all kinds of settings, so you can use it for the small handheld transceivers and CBs, things like that, that use very low power and very low deviations. And it can go right up to the necessary settings to measure the modulation coming out of high quality, high power broadcast equipment, broadcast transmitters. So it's very, very versatile. At the moment it's set on the 3 kilohertz deviation maximum, but it can be changed to all kinds of settings for commercial transceivers. Okay, so when we key up, it will detect the carrier, the meter will move to the left, and then when I start modulating, the meter will jump about trying to measure the peak deviation, which should be, if everything is right, around about the 2.5-ish, under 2.5. There's actually a little mark on the meter there, towards the right, little tiny arrow, which is the sort of point we aim for. So let's key up and see what happens. Keyed up, the meter's gone to the left. Now we speak. Hello, 1, 2, 3, 4, 5. Hello, hello. And as you saw, the meter is just under that little mark, which is on the scale we're using, the 0 to 3 kilohertz scale. That mark is at 2.5. So that's fine. That's a pretty perfect setting, that the deviation is what it should be without being so wide it spreads onto other channels. So that is everything transmitter wise working perfectly. I could look at the actual CB radio. It's going to be hard to zoom in on that. Let's see if we can. Just another little test. Try and zoom in on it a little bit. So that when we key up, the power meter on the CB radio indicates 4 watts ish, which is just on the borderline between the green and the red on the scale, usually on these radios. There you are, when you key up it's reading that. Quite often when these have been tweaked and twiddled over the years by experts, they think there's an adjustment inside which calibrates that meter. So the radio is putting out 4 watts, you then turn the adjustment to calibrate the meter so that the meter reads 4 watts to agree with the actual power of your test equipment. Well, people think that if they turn that adjustment way over, the meter bangs hard over when they're transmitting. They think they're getting a lot more power, but all they're doing is making the meter read higher. They're not getting any more power. Right, so next thing we want to do then is go to the signal generator. Now here we have a Marconi instrument signal generator buried amongst the rubble. We'll zoom in a little bit more on it. This covers quite a lot of frequencies. It's an old-fashioned analog meter, signal generator, quite an old-fashioned analog one. So they do have the snag that they do drift around. They don't stay on the frequency like a synthesized one, but they do have the flexibility that they can go on more frequencies and frequencies in between frequencies. And of course it will also work on AM or FM. When I had my digital synthesized one, albeit one of these cheap Chinese ones, that was FM only. But with this one I can test AM equipment as well as FM equipment. So the purpose of this, it generates a signal on any frequency that you wish. In this case we'll set it up to give us a signal on something like channel 20 on the CB, and you can set the signal generator to various levels. You can set it to give a very high strong signal or a very weak signal, and so it's also very useful for calibrating the signal strength meter, because like I said on these radios, you can calibrate that meter on the front panel, 4 watt signal, twiddle the adjustment inside so it indicates 4 watts. Then on receive you can give it a signal from the signal generator of strength 9. The signal generator has got a scale and you can set it to strength 9. It doesn't say 9 on the signal generator, it says something else. But you can generate a signal which is the equivalent of signal strength 9, and then you can adjust your CB radio internally so that the meter on the front panel of the CB says 9 on it. So a strength 9 signal really is a strength 9 indication on the meter. Excuse me. So that is one of the other adjustments that we can do. The other purpose with the signal generator is to go weaker and weaker and weaker with its output to see how weak a signal the radio can actually receive. And you tend not to do that by ear. You tend to plug in some kind of meter. When I did this professionally, working on radiograms in Ace Radio in Rill, we had a little audio meter which you connected across the loudspeaker, and you did the adjustments going by eye as to what the meter was reading in front of you. And we do a similar thing with these radios. Rather than do it entirely by ear, you go down until the meter is reading a particular reading, which is usually something like 12 dB cyanide is the standard that people go by. And so you reduce the signal strength coming out of the signal generator until your meter is reading 12 dB cyanide on your cyanide test equipment, and then you look at your signal generator and see how much signal it's putting out, and that gives you a sensitivity which is repeatable for CB radios. So if I measure a CB radio and say its sensitivity is such a figure, someone else in another workshop elsewhere in the country could do the same thing with their test equipment and they should get an identical result, whereas doing it by ear, it all depends on whether you're deaf or not. So right, we'll do that now. We'll bring it round, bring the meter round to the cyanide now. Zoom in a little bit. Oh, we're trying to be too precise. Right, so if we turn up open the squelch now on the CB radio and turn up the volume slightly, we will start measuring the noise coming out of the radio. And it doesn't have to be particularly loud, because these cyanide meters are very, very sensitive, and now it should read round about the 0. In fact, it's reading just below the 0, but it's about 1 dB below the 0. But it should read about 0 from the noise. But depending on the type of noise coming out of your radio and how well filtered it is, the reading can vary a little bit. So there we are, that's reading the noise. Oh dear, I'm talking too much, I need a drink. So now what we do is we put the signal generator on that channel, and you'll see that that noise will be replaced by the sound of the signal generator. But the way cyanide meters work, they don't measure the actual signal from the signal generator, they measure the noise only, or cyanide signal plus noise. So that meter will go down, indicating a lower reading. As the signal gets stronger, the meter reads backwards and goes lower, which is confusing. You soon get used to it, but it is confusing. So here we go, we'll give ourselves a signal now. First of all, we have to connect the signal generator to the CB radio. So here we have a lead with a connection to go on the signal generator. Usually a BNC connector on signal generators, and the 259 to go in the radio. And already, as you see, it's receiving the signal. But because this is an analog meter, it could possibly have drifted slightly off frequency, so we will check it. But at the moment, it's putting out a signal of 73 dB. The old style signal generators used to work in microvolts. And if you look at the old radios and the old spec for radios, it will say it can receive a signal of 1 microvolt or better than 1 microvolt. That's how they worked, microvolts, which was a fraction of a volt. But things have moved on, and the modern way of measuring is to work in dBs, which can be confusing for some of us old guys that were brought up on microvolts. But this is it, life moves on. Okay, so just twiddle the fine tuning a little bit because it's drifted. And if we look at the meter, so we can do that a bit better. We're putting out, as I said, 73 dBs, and the meter, if we look at it now, that is officially the official signal strength for S9. So if we look at the meter now, down here on the CB radio, as you can see, the meter is reading S9. So that has been correctly calibrated, so it's a signal strength of 9 from the test equipment registers 9 on the CB radio. Okay, we go back now to the cyanide meter. And we reduce the signal now coming from the signal generator, because as you see, the meter is hard over to the left, and we want that meter to be in the middle of that little green square. That is the official measuring point for sensitivity of 12 dB cyanide. So we'll reduce the signal now from the signal generator. And there we are, we're now more or less in the middle of that green area. And we look at the signal generator now and see how much it's putting out. And it's putting out 110, 18, minus 118 dBs. So the signal generator is giving us minus 118 for a 12 dB cyanide. So that is the official test figure for the sensitivity of this radio. We can say that this radio has got a sensitivity of that particular reading. Now we'll give a little adjustment on the fine tune just to check. No, that's it. That is it. I have to check because, say, with it not being synthesized, it can drift. So now we have a figure of sensitivity for the CB radio, and it's proving it's pretty sensitive. There's absolutely nothing wrong with that. It's got a sensitivity of minus, what did I say? Minus 118. And for the old guys who are used to working in microvolts, you can get conversion charts on the internet, and if we look here, minus 118 dBs, 679, minus 118, I find it on this chart. Minus 118 is 0.28 of a microvolt. Now generally in the olden days, if it was better than 1 microvolt, you was doing well. And here we are, it's 0.282 of a microvolt. So, you know, in the olden days you would say that was a very sensitive receiver. Things have changed these days. Stuff is a bit more sensitive possibly. But you're dealing with a very old CB radio, and that is as good as it gets. Even if you get a brand new latest model CB radio, they won't be better than that. In some cases they could be worse. So there we are, we've done all the tests on it. We check. Let's turn that noise down now. We've checked the transmit power, we've checked the deviation, we've checked the frequency, we've checked the receive sensitivity. So all in all, it's showing up as a very, very good, sensitive, spot on CB radio. Its only failing, as I say, is I was very disappointed with the chrome. Just go around there again. I was expecting beautiful shiny chrome as it showed on the tin, like the nice chrome shiny knobs on the radio, but all you're getting is the matte reflection from the lighting in the room here. So there we are, a thorough test of the CB radio, and you just cannot fault it. It's performing absolutely perfectly. Thank you for watching yet another one of my videos.